Have you ever contemplated the extent to which the power of a black hole can be felt? In this article, we examine a significant discovery that challenges our current understanding of the universe. Consider the following scenario: a force so immense that it propels streams of energy across the vast expanse of space, extending not just beyond the boundaries of its own galaxy, but across a distance that could span 140 Milky Ways, lined up one after another. This is the account of the observation of the largest black hole jets to date, a discovery that has left the astronomical community in a state of astonishment. The source of these remarkable jets is a supermassive black hole situated in a galaxy that is approximately 7.5 billion light-years distant from Earth. This indicates that the jets are being observed at a time when the universe was approximately 6 billion years old, which is nearly half of its current age. During this distant past, the universe was far more chaotic and violent, a period when galaxies were forming, merging, and often colliding with one another. In this turbulent era, black holes were some of the most powerful sources of energy, influencing the evolution of the cosmos in ways that are only now beginning to be understood. These jets are not merely large, they are in fact truly gigantic. Spanning an astounding 23 million light-years, they represent the largest recorded phenomenon of this kind. To contextualize this measurement in a more comprehensible manner, it can be stated that this diameter is over 200 times that of our own Milky Way galaxy. Such a scale is challenging to grasp fully, but it underscores the immense power and reach of these cosmic structures. The energy released by these jets is truly remarkable, with a quantity of energy that is trillions of times greater than that produced by our sun being emitted every second. What renders this discovery particularly intriguing is the nomenclature ascribed to these jets. The designation Porphyrion has been assigned to this phenomenon. In Greek mythology, Porphyrion was one of the most powerful giants, a fitting designation for a cosmic structure of such immense proportions. The name was selected by the research team, who drew a parallel between the ancient myths of Earth and the immense forces observed in the universe. It is noteworthy that the same team had previously identified another set of massive black hole jets, which they designated as Alcyoneus, another mythological giant. This set of jets was also remarkable, spanning the equivalent of 100 Milky Ways. However, Porphyrion has surpassed it, prompting scientists to re-evaluate their understanding of black holes and their influence on the universe. The discovery was made using the Low-Frequency Array, LOFAR, a European radio telescope that has been scanning the sky with unprecedented sensitivity. The LOFAR telescope has revealed more than 10,000 of these previously undetected enormous structures, a number that has surprised even the most experienced astronomers. Prior to LOFAR observations, giant jets of this nature were believed to be relatively uncommon. However, the new observations indicate that these structures are far more prevalent than previously thought. This has initiated a new field of study as scientists endeavor to comprehend the processes by which these jets are formed, the factors that contribute to their immense dimensions, and their role in the evolutionary history of galaxies. The jets observed in Porphyrion today are the residual products of a process that commenced billions of years ago. As matter falls into the black hole at the center of its host galaxy, some of it is ejected back into space in the form of jets. These jets are characterized by high energy and travel at nearly the speed of light, resulting in the formation of significant cavities in the surrounding space. With the passage of time, these jets can exert an influence on the growth and development of their host galaxy, and even on other galaxies in the vicinity. This discovery suggests that such outflows may have played a more significant role in the formation of the early universe than was previously assumed. One of the most intriguing aspects of this discovery is that the jets were produced when the universe was only about half its current age. At that time, the universe was much more active and dynamic than it is now. Galaxies were forming and merging at a rapid pace, and black holes were feeding voraciously on the gas and stars around them. This was a time of great change and turbulence, and the jets from Porphyrion are a relic of that era. Nevertheless, the most perplexing aspect of these jets is their remarkable stability and longevity. In order for these jets to have reached such remarkable lengths, they must have been active for a considerable period of time, potentially up to 1 billion years. This is a considerably longer lifespan than is typically attributed to these jets, which gives rise to questions regarding the factors that distinguish this particular black hole and its jets from others. It is therefore possible that the conditions surrounding this black hole were conducive to the long-term sustenance of the jet. An additional question that arises is whether there are intrinsic properties of this black hole that enable it to maintain such stability over such an extended period. To address these questions, astronomers have employed additional sophisticated instruments, including the Giant Meterwave Radio Telescope in India and the Dark Energy Spectroscopic Instrument in the United States. These instruments have facilitated the precise localization of the black hole and its jets, indicating that the host galaxy is a substantial one, exhibiting a mass at least 10 times greater than that of the Milky Way. Nevertheless, despite the wealth of data available, numerous questions remain unanswered. For example, the reason why some black holes produce jets while others do not remains unclear. Furthermore, the reason behind the remarkable expansion of the jets from Porphyrion remains unclear, particularly in comparison to the majority of other jets, which do not exhibit such growth. Furthermore, the black hole at the center of Porphyrion does not appear to be in the usual jet mode, which is a mode of activity that might be expected. Instead, it is in a state known as radiative mode, where energy is lost through powerful winds of particles rather than through jets. This was unexpected, as it was previously believed that black holes in radiative mode were unable to produce such large jets. The fact that Porphyrion's black hole is doing so challenges our understanding of how jets are formed and sustained. This discovery has significant implications for our understanding of the universe's history, particularly with regard to the evolution of magnetic fields. These jets are not merely energy blasts, they also carry magnetic fields with them, thereby dispersing these fields over vast distances. As these jets traverse the cosmos, they may be polluting the voids between galaxies with magnetic fields and energetic particles. This could have profound implications for the study of how magnetic fields in the universe evolved over time. The observation that these jets can persist for extended periods and remain stable even in the early universe underscores the limitations of our current understanding of the forces that shape our cosmos. The subsequent phase of the astronomers' research will entail an investigation into the impact of these colossal jets on the galaxies in their vicinity. One area of particular interest is the role of magnetism in these phenomena. The Earth's magnetic field plays a vital role in sustaining life on our planet. It protects us from harmful solar radiation and serves as a guiding force for a multitude of organisms, including birds and humans. The question thus arises as to the origin of this magnetism. It is postulated by the scientific community that the magnetic fields observed in the cosmos have their genesis in locations such as Porphyrion, where jets emanating from black holes disseminate magnetism across the universe. An understanding of this process could provide crucial insights into the origins of magnetic fields in galaxies, stars, and planets. Moreover, the narrative does not conclude here. The discovery of Porphyrion indicates the possibility of the existence of larger jets yet to be identified. Thus far, only a portion of the sky has been surveyed with LOFAR. As more of the universe is scanned, it is probable that additional colossal structures will be uncovered. The forthcoming Square Kilometer Array, SKA, a next-generation radio telescope currently under construction, will be even more powerful than LOFAR, thereby enabling astronomers to probe deeper into the cosmos than ever before. It is only a matter of time before a more extraordinary discovery is made. In conclusion, the discovery of the Porphyrion jets represents not only a significant advance in the study of black holes, but also a gateway to understanding the early universe. This period, which occurred when the cosmos was still young, dynamic, and full of potential, offers insights into the formation and evolution of the universe. This discovery challenges our understanding of how black holes grow, how they influence their surroundings, and how the universe itself has evolved. As we continue to explore the cosmos, discoveries like this remind us of just how vast and mysterious our universe truly is. It is likely that there are other cosmic giants out there, waiting to be discovered.